All right, hello, good morning. This week we've been talking about the atmosphere and the layers of the atmosphere and what the atmosphere is made of. And today we're going to talk about one important feature of the atmosphere, which is the greenhouse effect. So our objective of the day is I can explain the greenhouse effect. Okay, so the first question, what is the atmosphere? And if my slides would cooperate here. There we go. Okay, so the atmosphere is a layer of gases surrounding a planet. Our planet, obviously, is planet Earth. The atmosphere helps protect living organisms by protecting it from UV radiation, solar wind, and cosmic rays. Right, so here is a depiction of the layers of our atmosphere, starting with the troposphere, then the stratosphere, the mesosphere comes next, which is the coldest, then the thermosphere, the hottest, and then you have the exosphere, which just kind of blends out into space, right? It just keeps on going and getting thinner and thinner until you're finally in outer space. And scientists don't really agree on where is that final line where the atmosphere ends and space begins. It sort of just blends until the molecules are so spread out that it doesn't really count as the atmosphere anymore. So this is our atmosphere, and it's important to us for all of these reasons because it's protecting us from these things, these powerful radiation from the sun. Okay, so like we learned on, what day was it, Tuesday? The Earth's atmosphere consists of 5 different layers. And we talk about the layers as being either close to the Earth's surface or far away from the Earth's surface, right? So one's the atmosphere that is closest to the Earth's surface is the lowest altitude, right? And that would be the troposphere. Okay, and the higher in altitude you go, the further away you're getting from the surface of the Earth and the closer you're getting to outer space. So as we raise in altitude, we're getting into the stratosphere, the mesosphere, the thermosphere, and then the exosphere, which is practically outer space, right? So the troposphere is down close to the crust where we live. That's where all of the weather happens. All of the clouds that we learned about yesterday, 95% of those clouds are forming in the troposphere. A couple tiny cirrus clouds might get up into the stratosphere every now and then. Those really high-level clouds, the wispy, feathery cirrus clouds or cirrostratus clouds, those might get into the stratosphere every now and then. But mostly we're going to have weather down here in the troposphere. Okay, but the stratosphere is going to be important to us today. Because the stratosphere, sorry, let me go back to the slide, because the stratosphere is where the greenhouse effect is really taking place. So let's talk about what that means in a second. So while other planets in Earth's solar system are either scorching hot or bitter cold, Earth's surface has a relatively stable temperature because of its atmosphere. So the main thing that our atmosphere is doing for us is making our planet livable. It's making it warm enough that life can survive and even thrive, right? So we've talked before about how planet Earth is only livable because of a combination of things, right? It needs all 4 spheres to be able to be a livable planet. So other planets we see might have an atmosphere, but still wouldn't necessarily be capable of sustaining life unless they also had a hydrosphere, a geosphere, and a biosphere. So the atmosphere is just one part of what makes Earth a livable planet. Okay, so go ahead and pause your video. Let's go answer the first question on our Google form, which is, what is the second layer of the atmosphere called? The second layer. So I'm counting from the surface of the Earth towards outer space. So the lowest altitude to the highest altitude. So tell me, what is the layer above the troposphere? Okay, and when you're ready, you press play, and the answer is the stratosphere. Stratosphere, like I hinted at you earlier, the stratosphere is what we're going to focus on today because that's where the greenhouse effect takes place. So the greenhouse effect is, well, let's talk about it. First, let's talk about what is a greenhouse. Okay, let's all get on the same page. But what is a greenhouse? So a greenhouse, you might have seen one before. Maybe you have one in your backyard, or maybe somebody in your family has one, or sometimes you can see them on the side of the road. Big houses made of glass, mostly used for growing plants. And the reason it's used for growing plants is because a greenhouse has the ability to stay warm on the inside, even during winter, even when it's really cold outside. As long as it can collect sunlight, it can stay warm on the inside. Okay, so this is a view inside of a greenhouse. So all the important part of a greenhouse is that it's made of glass or made of window panes, right? Transparent sheets that light can get through. So the sunlight shines in and it warms up the plants and it warms up the air inside. But the heat is trapped by the glass and it can't escape. So the heat that gets in, some of it can go out, but a lot of it stays inside. Most of that heat gets trapped inside and cannot exit the greenhouse. Okay, so pause your video and let's go to question number 2 on the Google form. Tell me, how does a greenhouse help to keep plants warm in the winter? Okay, so in a place like Colorado, a greenhouse is super effective and super important if you're going to be growing crops or vegetables or plants over the winter, because a lot of plants can't survive in the frosty cold, right? Some plants are adapted to do so, but there's a lot of plants, especially vegetables and fruits, that can't survive in the cold. So a greenhouse helps because as the sunlight comes in, right, the sun's still shining even when it's really cold outside. So as the sun comes in, it warms up the inside of the greenhouse, and then the heat stays trapped in there thanks to those windows, thanks to that glass. Okay, so now the question is the Earth similar to a greenhouse? Or how is the Earth similar to a greenhouse? So the short answer is yes. Earth's atmosphere does the same thing as a greenhouse. So gases in the atmosphere do what the roof or the windows of a greenhouse does. Okay, so in this example, we can see the sun and the earth, okay, and the heat from the sun beaming down on the earth. Okay, and the heat from the sun is able to get into the atmosphere. It goes through the atmosphere. And as that heat hits the earth, right, some of it's getting absorbed and some of it's bouncing back off the Earth. You see those arrows that are bouncing back off of the Earth? So this heat and light that's getting reflected back off of the Earth, okay, some of it is able to escape back out into space, right? That's what we see as Earth shine, something called Earth shine, right? That's why planet Earth glows bright when you look at it from outer space or when you take a picture of it from space. It's shining, right? Because some of its light is reflecting off the surface, or some of the light of the sun is reflecting off the surface. But some or a lot of this light and heat is not making it back into outer space. Do you see how it's getting trapped? It's getting stuck in that atmosphere layer and just bouncing back and forth between the Earth and the atmosphere. So it's continually being reflected off the atmosphere and the Earth right here. Okay, so this is what is keeping Earth nice and warm. If we didn't have this atmosphere cushion around our planet, all of the heat from the sun would be bouncing back off of the planet and going out into space, or a lot of it. Some of it would still get absorbed, but a lot of it would be escaping back out into space, right? And thanks to this cushion right here, it's trapping some of this heat and some of this light from the sun, okay, and keeping that energy close to the Earth. So let's talk about what exactly is causing this effect. Okay, there's something called a greenhouse gas. And greenhouse gases are specific types of gases that are able to trap heat in the atmosphere. Right? It's not every single gas in the atmosphere is causing this. There's specific molecules that keep the heat of the sun inside. So some of these are pretty common gases that you've heard of before. Let's see how many you recognize. Okay, so I'll read what it says at the top. Greenhouse gases trap heat in the atmosphere, which makes the Earth warmer. So the primary greenhouse gases in the atmosphere are water vapor. I know you know that one. We've talked about water vapor before. That's also part of the hydrosphere. Remember, water vapor is one of those that kind of toes the line between hydrosphere and atmosphere. It's really a part of both, just like clouds. Okay, carbon dioxide, another familiar gas. Then we have a few that you may or may not have heard of before. Methane, nitrous oxide, and ozone. These are gases that occur naturally on Earth, but they're also gases that we as humans can create. We can make more of them, and that can lead to problems. We'll talk about that in a second. Okay, so these are the main greenhouse gases. Water vapor, CO2, those are really common ones that you've heard of before. And then you have methane, which is what you smell when you pass gas. It's released from cow manure, and it's also released from decomposing things like rotting plants. And then you have nitrous oxide and ozone. Ozone kind of looks like oxygen, but it has it's 3 oxygen molecules instead of 2 oxygen molecules. So it's not the same as just the regular oxygen that's in the atmosphere, right? We learned on Monday that 21% of the atmosphere is oxygen. That's not the same as ozone, right? There's less than 1% of ozone in the atmosphere, okay? So it's a little bit different. Oxygen is not one of the greenhouse gases. Ozone, which is a totally different molecule, is a greenhouse gas. Okay, so pause your video. Let's check your understanding. Go ahead and go to question number 3 and tell me 3 greenhouse gases. write the names of 3 greenhouse gases. I don't mind if you write their name or if you write the chemical formula. Either way is fine with me. Okay, moving on. So these gases used to have an equilibrium in the atmosphere. That means they used to be balanced in the atmosphere. But people, humans, humanity, we are adding several types of greenhouse gases to the atmosphere. So we're making it unbalanced. Human activity is disrupting the balance of these gases in the atmosphere. So through factories, pesticides, our agriculture practices, driving cars, flying planes, all these things we do that cause air pollution are really adding a lot of these greenhouse gases to our atmosphere. And let's talk about a few of those activities. So human activity increases greenhouse gases in our atmosphere, from driving cars, to flying planes, to using electricity. Sorry, I don't know why that thing keeps popping out and popping back again. Having livestock, raising livestock or farming livestock has a huge impact on greenhouse gases. Tons of methane released from fields of cow manure and just fields of cows in general. And then burning things, burning fossil fuels, burning coal, also burning, forest fires or slash and burn farming. All of those, anytime that you're burning something, it's adding carcinogens and adding greenhouse gases into the atmosphere. So, and again, these things are naturally occurring in the atmosphere. They're not all bad. It's just that if you throw them out of balance, if we have too much of them, they can start to trap too much heat from the sun. And that's what we're starting to see happen on our planet, right? Is that the greenhouse gases in the atmosphere, which are used to being in balance, are suddenly getting tipped a little too far in they're just increasing a little bit too much, is what I mean. And so they're trapping more and more heat from the sun. And you might have heard the term global warming, right? Or climate change. That is mostly being caused from this extra amount of greenhouse gases in our atmosphere. Okay, and these are just some of the activities that can add greenhouse gases to the atmosphere. Okay, I could also put, having factories on here, or mining on here, mining for, rare metals. There's all sorts of activities that we do, which unfortunately produce a lot of gas. So let's recap. Go ahead and pause your video and go to question number 4. Tell me 3 different human activities that could increase greenhouse gases. Okie dokie. All right, so finally let's get down to it. What is the greenhouse effect? The greenhouse effect is the process by which radiation, which could also be called heat or light, from the atmosphere warms the planet's surface to a temperature above what it would be in the absence of its atmosphere. So that's a wordy definition, but what it means is that the greenhouse effect basically means that the atmosphere is keeping our planet warmer. Without our atmosphere, we'd be colder, right? The atmosphere is helping to trap heat from the sun. What we need to be careful of is that there's this difference between this natural greenhouse effect and the human-enhanced or human-caused greenhouse effect, right? In this natural greenhouse effect, the heat from the sun balances with the atmosphere, and our planet's able to stay at a stable and healthy temperature. With the addition of all the humans on Earth and the human activity, all of us driving our cars, all of us, flying planes and using electricity and all the things that we do to add greenhouse gases to the atmosphere, it's causing our planet to be warmer than it should. Okay, so there's just a lot more of these gases, the CO2, carbon dioxide, methane, nitrous oxide. Okay, so there is more heat getting trapped in our atmosphere than usual. And we're throwing the planet out of balance a little. Or a lot. Okay, so the greenhouse effect not only causes a rise in the Earth's temperature, but it also is like a ripple effect or a domino chain, right? It can cause more drought, or conversely, more flooding. It could cause less ice and snow, right? Cause glaciers to melt. And it can also cause rising sea levels. It causes the sea to rise and potentially flood coastal cities. Okay, so pause your video. We're on question number 5. We're almost done with the lesson. We're on question 5, which is, what is the greenhouse effect? What is the greenhouse effect? Okay. And finally, last part of our lesson, let's talk about what can you do to help stop this greenhouse effect, or to help reverse the greenhouse effect. Okay, so here are 8 steps that you can take to reduce greenhouse gas emissions. Some of these you already know, and some of these you've heard before. Okay, first of all, reduce, reuse, and recycle. Okay, by recycling half your household waste, you can save tons of carbon dioxide annually. Literal tons. Use less heat in air conditioning. So turn down the heat while you're sleeping at night or while you're away during the day. And it actually helps you sleep better if your house is colder. Okay, and some of these things, obviously, you're going to need your parents' permission to make these changes in your life. Replace your light bulbs. So if you use CFL bulbs or LEDs, that will help reduce your electricity use. Drive less if you can. In fact, it's funny. The quarantine that we're all enduring right now because of the coronavirus, the novel coronavirus, it's actually helping us accomplish a lot of these things. I don't know if you've been seeing in the news all of the different reports from around the world of ways that the air pollution has actually decreased. And for example, in India, I saw an article yesterday saying that they could see the Himalayan mountain range because the smog was the lowest that it's been in years. And because people are staying home and they're not driving to work and they're not going out and driving their cars. So, yeah, and same in China. I've heard the reports that people who were used to seeing really cloudy, smoggy, hazy cities, we're seeing clear skies for the first time and hearing birds singing for the first time, and we're lucky in Colorado that our air quality is actually very good where we live. We're really blessed for that, and because of that, I haven't really noticed a difference here about the air quality, but all over the earth, even just staying home for a couple of weeks has drastically improved the quality of the atmosphere, okay, and helped to reduce these greenhouse gases. So it's really interesting. It's truly effective, just driving less, or walking more and biking more. I hope this continues to be a part of our life even after quarantine is over. So if every American family replaced one regular light bulb with a CFL light bulb, a fluorescent light bulb, it would eliminate 90 billion pounds of greenhouse gases. That's how much our electricity is causing greenhouse gases. It's honestly wild. Okay, just a couple more things that you can do. You can conserve hot water, use less hot water, or turn your heater down. You can use the off switch, so turn off lights when you leave the room. And also, my favorite idea is you can plant trees. Trees absorb, right? Trees are our friends. Trees absorb tons of carbon dioxide during their lifetime. And that's one of the reasons that, the rainforest is so important to us, and all forests are important to us. Not only are they providing oxygen, but they're also sucking up a lot of these greenhouse gases, including, or mostly, carbon dioxide. And finally, educate. Share information about recycling and conservation. Okay, educate each other, help each other. If you notice your family, just leaving lights on or not recycling or driving when they don't need to, all those things, be the encourager. You don't have to be rude about it, but you can be a voice of encouragement and say, hey, let's walk to the park, or hey, let's turn off the lights when we leave the house, or, I would love it if we could recycle, mom and dad, or auntie, uncle, whoever you're talking to. There's ways to be a force for good without being a terrible nag. I encourage you to try. Okay, here's number 6. Last question on your Google form. What is one thing you can do to stop the effects of global warming, or to stop the effects of greenhouse gases? What's one thing that you can do? Maybe you're already doing it. Maybe you haven't started yet. But what is one thing you could continue to do, or you could start doing? Okay, that's the end of our presentation today. Love you very much. Thank you for sticking with me. I appreciate it. Hope you learned something cool about the greenhouse effect in our awesome atmosphere. It's a really, helpful feature of the atmosphere. It's what's keeping us alive. But if we don't take care of our atmosphere, then, its superpower will turn on us, and it'll start keeping our planet too warm, right? We can't abuse the atmosphere, or it will no longer serve us. So we got to take care of it. Now is the time for you to go and take your DOL. So go back to your Google Classroom and take your DOL, your demonstration of learning. Once you take that, make sure you click View Your Score, and you can get started on LSAE. Okay? Love you, and talk to you later. Bye.